Good morning all. How are you? Welcome to my channel Vijay Physics Sprint. Today I am going to explain about horizontal projectiles. Last class I explained about oblique projectile. So please follow that video about projectile information, oblique projectile, and the next concept is horizontal projectiles. So what do you mean by the horizontal projectile? For example, a body is projected from top of a tower or from top of a mountain, for example. So the type of projectiles, so this is the mountain or the tower. Let the tower height is given by h. The body is projected horizontally. So if the body is projected like this, then the angle with the ground it is theta. That is the type of projectile is called as oblique projectile. Now the body is projected horizontally, no angle, no elevation, simply horizontally the body is projected. So that type of projection is called as, so this horizontal projectile, right? The type of projectile it is called as horizontal projectile. The initial velocity of the body is given that u and it reaches to ground. Okay. Now what is the range covered by this projectile and how much of time taken by the body to reach the ground, and what is the velocity when the body impact the ground, and what is the angle made with the ground when it reaches to ground. So I am calculating here on projectile motion, horizontal projectile. So horizontal velocity u and initial vertical velocity is 0. Initial vertical velocity uy equal to 0. So applying the second equation of motion, that is y equal to uyt plus half gt square. Y is nothing but height h. So h is equal to uy is 0. 0 into t, that is 0 of gt square. So time becomes root over 2h by g. So this is the time taken by the body to reach the ground. So t is equal to root over 2h by g. So t depends upon the height of the tower or height of the building. So t equal to root over 2h by g, the time taken by the body to reach the ground. And what is the range? How much of distance covered by the body? How much of distance covered by the body? Nothing but range r. So applying the same second equation of motion with respect to x-axis, that is ux is equals to uxt plus half ax t square. Ux is nothing but initial velocity is u. Initial velocity no change, but the vertical velocity is going to be changed. This is ux, uy, and this is ux, which is equals to u and uy. So ux remains same, which is equals to ux no change. Therefore, the acceleration in horizontal direction is equals to 0. Then x is equals to ut, ax value is 0. The second term is completely going to be 0. Then x is equal to ut. This is the range equation. X is nothing but range r equal to u. T, time already we derived, that is nothing but root over 2h by g. So this is the range expression for the horizontal projectile. So range depends upon initial velocity of the body and the height, and time depends upon the height of the tower. Range depends upon height of the tower as well as the velocity of the projectile. So this is horizontal projectile. And what is the velocity when it reaches to ground? Velocity is nothing but no change in initial velocity, but final velocity, the vertical velocity is going to be changed. So what is the final vertical velocity? V I am calculating. That is V equal to u plus at. Already we know this is the first equation of motion. With respect to y-axis, uyt, uy plus ayt, that is Vy equal to uy, initial vertical velocity is 0, ay which is equals to gt. So therefore the final velocity v equal to root over vx square plus vy square. Vx nothing but initial velocity is no change, so vx or ux which is equals to u. Therefore v equal to root over u square vy already we derived vy square nothing but g square and t square. So this is the final velocity of the projectile when it impacts the ground. When it impacts the ground, final velocity v equal to root over u square plus g square plus u square plus g square into t square and root over. Now what is the angle when it makes the ground impact the ground? We know that tan theta direction or angle with respect to ground, tan theta is equals to vertical component of velocity by horizontal component of velocity. That is tan theta is equals to, what is the vertical component? Vy. Vy is equals to gt. Horizontal component vx or ux which is equals to u. So therefore the angle with ground tan theta equals to gt by u or theta equal to tan inverse of gt by u. So this is the angle made by the projectile when it impacts the ground. Okay, so this is time expression, this is time expression, and this is for range expression, and this is velocity when it impacts the ground, and this is the angle when it reaches the ground. So okay, that time expression, range, final velocity, and angle when it reaches the ground. Now some more information about this projectile motion. That to be horizontal projectile. Right, the body is projected from top of a tower. The projectile motion. Right, initial velocity is given u, and there is an angle of elevation. Angle of elevation taken as alpha. What is the relation between this angle of elevation alpha to theta? Theta means when the body impacts the ground, the velocity makes an angle theta with respect to ground. So the angle of elevation alpha and the angle when it reaches to ground theta. I am reducing the relation between this alpha and theta. So this is the height h. Okay, and this is the range r. From this triangle, I am writing the value of tan alpha. Tan nothing but opposite by adjacent, that is equal to h by r. But we know that h is equals to of gt square. Okay. Range is nothing but horizontal velocity into time. I am substituting here, that is tan alpha equal to h of gt square, range ut. Okay, now t is cancelled, then remaining tan alpha equal to gt by 2u, gt by 2u. But gt by u here I wrote. So tan theta equal to gt by u. In place of gt by u, I am substituting tan theta, that is tan alpha equal to tan theta by 2. So this is the relation between angle of elevation alpha to theta when the body impact the ground. So tan alpha equal to tan theta by 2. So it's a very important relation. The angle of elevation to the angle when reaches to ground, tan alpha equal to tan theta by 2. Okay, now see these three different cases. Top of height of the tower, it is same h. In these three cases, height it is same. The body is projected different cases. One, it is horizontal direction. This is a horizontal direction u, and second it is projected upwards with same velocity, and third case projected downwards with same velocity. These three bodies are projected from same height with same velocity but different directions. One it is horizontal direction like this, the horizontal direction, and second it is projected upwards, and third is projected downwards. So three different cases. So in the examination, the question just you have to observe related to which case. If it is horizontal direction, then you can use directly h is equals to half gt square. H is equals to half gt square, and time root over 2h by g, range, velocity into time. So this is the horizontal projectile motion. When the body is projected upwards, now it's like a oblique projectile. This is the base, is like oblique projectile. To solve this type of problems, now we can use h is equals to minus u sine theta t plus of gt square. Velocity u resolved into two components, horizontal velocity and vertical velocity. So h is equals to minus u sine theta t plus of gt square. When the body is projected up, when the body is projected down, right, theta with horizontal and u velocity is downwards direction. So to solve this type of problems, you can use h is equals to u sine theta t plus of gt square, and correspond you can calculate what is the time. There also you can calculate time, and of course range. Range is nothing but horizontal velocity into time. Horizontal velocity means ux means u cos theta into t. There also ux into t, that is u cos theta into t, and final velocity you can calculate. Of course angle also you can calculate in these three different cases. Okay, now we'll see some more applications on horizontal projectile. Right, if two towers are mentioned and the person or a body jumping from one tower to another tower, right, the person is jumping from, or the body is jumping from one tower to another tower. The height of the tower it is h1, and second it is h2. Second it is h2. Okay. Now the person jumping from one tower to another tower horizontally. Right? I think you can see some ads, Pepsi ad or Coca-Cola ad. Right? The actor jumping from one tower to another tower to catch that bottle. Right? For 20 rupees of bottle, they are taking, total life is in risk. Right? You can see that type of ads. So the person jumping from one tower to another tower, the distance between these two towers, which is taken as d, the distance between these two towers. Now, how much of time take to reach the second tower? So, such type of problems, you can take the height difference between these two given towers. Height difference is nothing but h1 first tower height, h2 second tower height. Height difference becomes h1 minus h2. Right? I am calculating time, that is h is equals to half gt square. We know this equation. H is nothing but height difference, h1 minus h2 equal to half gt square, and then time becomes 2 h1 minus h2 by g, and of course root over. So this is the time taken by the person to jump on the second tower. Now what is horizontal distance? Horizontal distance is equals to horizontal velocity into time, that is distance d equal to velocity time. Just now we calculated 2 into h1 minus h2 by g. So this is the horizontal distance. This is one of the application in horizontal projectile. Now one more application. See the one more application. The ball, it is rolling on its stays. The ball rolling on its stays. each state height is h. H is the height of each state. Width of the stair is equals to b. Right? What is h? Height of the stair. B, width of the stair. The ball jumps or rolls on stairs, directly hits on nth stair. It may be 10th or it may be 20th or 50th, whatever it may be. Simply I am taking nth stair. Height of stair is h, width of stair is b, directly strikes the nth stair. Then how many stairs I am calculating here, right? So this is the height and this is the range. Range is nothing but r is equal to velocity into time, range expression. But range is equals to b, like n number of stairs. So n into b equal to ut, equation 1. Okay, and the height h is equals to of gt square. This is the each step height. Like we have n number of stairs, h total you can calculate. So it becomes nh equal to of gt square. From equation 1 I am writing time t equal to nb by u. Substitute here, nh is equals to of g t square n square v square by u square. N is cancelled. Solving for n by cross multiplication, 2h u square by g b square. So this is the number of states. So on this also you will get one problem, right? Calculate number of states. If each height of the stair is 10 centimeter or 15 centimeter, width it is 5 centimeters, some different data will be given. Then calculate how many number of states. Then you can use this equation or you can follow this method also. N equal to 2h u square by gb square. One of the application. Now one more application on this horizontal projectile, and it's a very important application. I will give the shortcut formulas for this application. Okay. From top of a tower, let h is height of the tower. Two bodies are projected opposite to each other. The first body is projected with velocity u1, right? Like this is projected. And second body with velocity of u2, opposite to each other. Then remember 4 equations on this concept. I am writing the shortcut formulas here. Two bodies are projected opposite to each other with velocities u1, u2 from same point of the tower. Height of the tower it is h. When velocity vectors of those two bodies making an angle theta. The velocities of the vectors make an angle theta with respect to each other at the time as well as distance. Velocity vectors are making angle theta with respect to each other at the time of t equal to root over u1 u2 by g cot theta by 2. At this time the velocity of those two bodies is theta, and at that time the distance between these two bodies x is equals to u1 plus u2 velocity into time it is equals to u1 u2 by g cot theta by 2. This is for velocity vectors. Read the question carefully. Sometimes instead of velocity vectors it will be given the position vectors. The position vectors makes an angle theta with respect to each other at the time of t equal to 2 root over u1 u2 by g cot theta by 2, and at that time the position or the distance between those two bodies x is equals to u1 plus u2 into time, that is u2 into u1 u2 by g cot theta by 2. If you remember this velocity, you will get automatically this position vectors. Simply you can add 2. Just multiply with 2. So t equal to 2 root over u1 u2 by g cot theta by 2. For velocity vectors makes an angle theta with respect to each other, and position vectors t equal to simply multiply with 2 into root over u1 u2 by g cot theta by 2. So remember these four equations, very important. Most of the questions will come on these concepts only, on these methods only. Okay, if you have any doubts, you can make in the comment box, and please subscribe, share and support my channel. Thank you all. Bye.